Hey seniors, so in this video I just want to show you some cool, important calculator tools that can help us calculate derivatives as you all start Unit 3. Unit 3 is like the last prep derivative unit before we start applying our derivative knowledge to really cool problems. And I want to show these off so that they can be a tool to help you check your work all throughout this unit and for any more derivative problems that you attempt. So this is a question straight from College Board. It's actually a progress check, which you can take to replace a Unit 2 test. And I'm going to give away 3 answers right now, so just keep that in mind. But this question is saying the derivative of a function f is given by this function f prime of x, which equals what you see right here. Notice how we're not given the original function. We're just given the first derivative. So this expression right here is only going to describe the slopes on the original f of x function at certain x values. What we're going to see in a second is not the original function. We actually don't know what that function looks like. We will know how to figure that out come Unit 6, but that'll wait till Unit 6. And so our challenge is, at what x value does the slope of the line tangent to the graph of x, when is that slope 2? So I wanted to walk through how we could do that. By the way, if you see this orange calculator on a College Board question, it's saying that it's a calculator question, that we don't really have the easy to use skills to solve it without one. So that tool is going to be our best bet. So let me pull up my online graphing calculator and let's dive into this. So what I'm first going to type in this function space is just the function that you see. Now I'm going to type it into y equals, even though we know this expression is expressing the first derivative of the function f of x. So let's see, X button's right there next to alpha and then plus. You can do a second right here for the division sign and E will pop up. You can also do second, and then right here, the natural log sign has e to the x already raised to the exponent. And then it's just 0.25x, and here's the function. So let's graph it. And this is what it looks like. So it's still following sort of that natural log progression. And then notice how if I say trace, it gives me the point 0, 1. Reminder, that's saying on the original function, when x equals 0, the slope at that point on the original function is 1. Because derivatives just tell us what is the slope at any given point on the original. This is saying that the point y equals 1 is saying the slope on f of x, right when x equals 0, would be 1. If we drew a tangent line, it'd have an exact slope of just 1, up 1 over 1. The question is, how can we figure out, well, when is this going to have a slope of 2? So we're really looking for when the output is 2. So if I trace this function, you can see my y values are increasing, it's like 1.8. And so it looks like around 2.2 to 2.4, but I can't just calculate it right now. And I can't just say x equals 2, because that's telling me what is the slope on the original function when x equals 2. And that slope would be 1.8 approximately, but that's not the question. The question is, at what x value does the original function have a slope of 2? So what we can do is figure out when is the output value, when is the y value equal to 2, just graphing 2 as a line on this function and figuring out when these functions intersect, because that exact value, when the output is 2, the x value at that value would be when the slope is equal to 2 on the original function. So to figure out how to find intersect features, we want to hit second and trace. We have actually a lot of really cool features. We have all these you're seeing right here. We can also scroll down to see the intersect function. And so now all I want to do, intersect function is pretty easy. You just want to kind of scan over, like hit the arrows over to the point and just hit enter 3 times. And what that's telling me is right when x equals 2.286, that is when the output value is 2. And so that's telling us, because again, the blue line is the derivative function, that on the original function, when x equals 2.286, the slope at that point must be 2. So if we look at our answer choices and minimize this, we're seeing that looks like C is our best answer choice. And I have the teacher functionality, so I can see, yep, the right answer is C here, and it gives you a little explanation as to why. I'm going to show you quickly how we could also do this on Desmos. I can start by saying, I'm going to say g of x equals f prime of x. That's not anything for Desmos. It's just for us saying, when I type in g of x right now, we know that's referring to f prime of x. And now memory, 0.1x, and then plus e. If you'll hit second 6, it'll raise that power, so I can just easily type in 0.25x. We're seeing the same thing. We're seeing that point we saw 0, 1. So when x is 0, the slope is 1 on the original function. We're also seeing that Looks like when x is negative 3.83, the slope on the original function is 0. That's implying a horizontal tangent, so it must be decreasing and then going back up there. You're going to explore that more in Unit 4. So now we can do the same thing where I say y equals 2. And then Desmos is really nice because it automatically calculates that intersecting value. So we're seeing that when x equals 2.287, the y value is 2, which again is referring to the slope on the original function. So always keep that in mind. The derivative function serves a very particular purpose. It is a function in itself, but if we're trying to figure out what it means in terms of the original function, it's referring to the slope at any x value on the original function. So let's dive into another example. Okay, so in this example, we are given an original function. We're being told f of x is equal to 2 to the x cubed. And it's saying the selected values of f are given from the table above, and that makes sense. If I plug in 0 to this function, 0 to the third is just 0, 2 to the 0, anything to the 0 is 1. The point 0, 1 makes sense to be on that function. If I plug in 1, 1 to the third, 1 times 1 times 1 is 1, 2 to the first is 2. Those points make sense. Now it's saying if the values in the table are used to approximate f prime of 0.5, what is the difference between the approximation and the actual value of of f prime of 0.5? This is saying, can we use our approximation skills to approximate the derivative, and then can we find the exact using our calculator skills and compare how close is our approximation to the exact value? And a reminder that if I want to approximate any derivative, any rate of change, what I can do is find just the slope between points that sort of surround that x value. So now that 0.5 is between 0 and 1. So I wanted to approximate that. What I could do is this. I could say, okay, f prime of 0.5 is going to be approximately just y2 minus y1 over x2 minus x1 of the surrounding x values, which luckily I have that table of values. So I'm really saying, my y2, 2 minus 1, and then subtract 1 minus 0, and that's going to be an approximation, not the exact slope, but an approximation of the slope right at a 0.5. So I'm going to have 2 minus 1, and all divided by 1 minus 0. This is true if you're ever asked to approximate a derivative, you don't have more information, you can just take the really close surrounding x values for the actual x value you want to approximate the slope for. And this is always going to be a way to approximate, not get the exact value. So it looks like we're arguing the approximate slope is right at 1. And now our challenge is how close is that actual approximation to the real derivative value. So let me bring up my graphing calculator again. Pull it up here. So it looks like if I go to y equals, to type this function, I can hit 2 and this little upward arrow and type in my x variable. I can do it again for the third power. Can I type in 3? Yay. And I can hit graph. So let's see what this function looks like. Now, I want to know right at when x is 0.5, so let's zoom in a bit. If I hit zoom and n, you always zoom in and out on TIs by a factor of 4. So I hit enter again. So here's a closer look at this, and we're wondering what is the slope right here at 0.5. Now notice my cursor is already on there from going through this, but the slope is not 1.09. That's the actual xy pair. Again, we are given an original function. It just relates to x and y pairs like normal functions, but we want to know the slope. What's really cool is your calculator has that function built in. If I go second trace and I go down to dy dx, I can also just type in 6, but I can scroll down, hit dy dx. It's looking for an input value now. You want to tell the calculator what slope do you want to find. So if I just type in 0.5, we're going to ask it what is the slope on this function when x is 0.5. And then notice it tells you right there, 0.566. Like that is dy dx at that value. That is the slope at that value. Now, all we want to do is subtract that from 1 because we're trying to compare the exact slope to our estimation. So you can probably already guess the answer is going to be B. What's also cool is if I hit second quit and just get out of this, if I hit the store button and store an x, what it's going to store is the last output, which was the slope. So now I actually was able to store my slope value in a variable. So now whenever I type in x, it has that, which makes it really nice to just save that value for AP questions, or if you just wanted to save it. Now I can do the difference between my estimation, which was 1, and the actual slope, which was 0.56. So I'm off by about 0.43, which is a pretty good error. So it's nice to have approximations to be in the ballpark, but we're pretty far off on this one. So the answer is going to be B because that's the difference between our estimation of 1 and the exact slope at that point, which is 0.56 approximately. Let me show you really quickly how this would look on Desmos. I'm going to clear off all my work. Clear all drawings, and let's bounce over to, so again, I could say f of x is equal to 2 to the x to the third. So that's our function right there. And again, if I want to do, this is actually a lot easier on this one. If I just do f prime of 0.5, there's our slope at that point. If I wanted to figure out what is our approximation, I'm just doing, f of, because we're given f of, I think 1 and 0. Let me go back to the question real quick. Yeah, 1 and 0. So I could say, well, f of 1, y2, minus f of 0, y1, and that whole quantity divided by just 1 minus 0. We're given our approximate value right there. So again, I could just say, this value, I could just say minus f prime 0.5, and it would calculate it right away. So Desmos is pretty user-friendly. If you don't want to use your graphing calculator, or you just want to use this instead. One more example, and that's it for this video. All right, for this last example, all we're doing is we're given this function f of x, which is a pretty long polynomial, and it's saying which of these statements is true. So it's really saying with all these f primes, can you find the slope at all of those points, then figure out which slope is greater than the other slopes in the correct order. So pretty easy ordering from looks like least to greatest. So from here, I've already typed in most of this function because I don't want to just have you watch me type, but just some calculator tricks. If I hit alpha y equals, I'm given the option for a numerator and a denominator, so I can just hit enter and then type in 15 over 4 pretty easily, which I just like doing that, so it sort of arranges it just like we see the function. This works for 84, so if you don't have an 84 and you want to type a fraction, you could just type the fraction in. I feel like sometimes it might violate order of operations, so I always do this where I just put parentheses and then I do just a fraction just with division in parentheses to make sure like that is showing a clear fraction. And raised to the third power, and then last is just plus 6x squared. And now let's graph this. It took a little while to go, but here's the graph of this function. So now if I want to figure out the slope at all those places, real simple. All I do is just hit second calculate. I can hit 6 for dy dx, and then I just want to type in the x value in question. So I'll type in the most negative one to start, so negative 3.1. And it's saying that very steep positive slope 14.97 at that point. If I want to remember this, I can just hit second quit. Let me clear all this off because I already practiced this, and then hit the store button. And this time I'm going to store it in a letter just so I don't have to keep using x and I don't overwrite x. So I'm going to hit alpha and math, which will give me the green A option. So now every time I type the green A, I know that's the slope on this function whenever x is negative 3.1. So I have that stored. Now let's go back to the graph and hit second trace, and then 6, or you can just scroll down for dy dx. We're going to type in negative 1.5, hit enter. Looks like the slope is 4.92, and I'll hit second quit again, store. This time I'm going to hit alpha and the apps button for the letter B. So now every time I type in alpha and type in B, it's stored that value for me. And now I can hit graph and go second trace and hit 6 for dy dx to find the slope there, and then just type in 0.4 for our x value. Looks like our slope right there is 4.38. So now let's hit second quit, store. Then alpha, I'll go to programs so I can get the C button. So now I have all these values stored. So I can see that it looks like the biggest slope is actually when x is negative 3.1. The next biggest is B when x is negative 1.5. And the smallest is when x is 0.4. So it looks like option D is going to be our best answer here. And that is true. Just ordering the slopes from the smallest value to the greatest value comparatively. For Desmos, I already wrote it out for you, so we don't have to watch me. But again, Desmos is nice and easy to do this with. I can hit f prime of negative 3.1, and it auto calculates that as long as I have f of x typed in, negative 1.5, and then f of 0.4. And again, you can see that it looks like here's our smallest slope relatively, our next biggest slope, and our largest slope for this function at those given points. So here is your all's actual assignment for this one. Submit these notes because I want to make sure you have them. And then I want you all to try this problem that I'm going to screenshot so you have access to it. The very first question on part B of these progress checks, which again, you could take, and it could replace your Khan Academy or your Riggs test score, so think about it. But all you're going to do is using our calculator tricks, can you figure out if this is the function given, where are their x values so that the slope on this function, whenever it's 1/2, what are the x values that we input to figure out the slope right at those values? So that's going to be your challenge question. I'll screenshot this and I'll put expectations for what I'm expecting from you. I hope this was helpful. As always, let me know where you're at. And yeah, you all got this. Keep it up.